Hi, welcome back. Let us continue our discussion regarding the integration of rational fractions. Last time we take the case 1, which is the denominator of our integrand consists of a distinct linear factors. Okay. So last time we solve the we solved the 2x plus 5 all over the x squared minus x minus 2 of x, right? So this time we're gonna evaluate the x squared plus 1 and then all over x squared minus 1 d of x. Okay. So as uh, as as you can see here for our example 1. So our example last time is in terms of the what we called a proper rational fraction. Thank you po. Salamat po. Okay. So how can we say that it is a proper rational fraction? We say that our numerator denoted as p of x and our denominator denoted by q of x. So in order for us to say that it is a proper rational fraction, the degree, if you remember last time, we say that the degree of our p of x must be less than q of x. Okay, so let's analyze the degree of our p of x. So the degree of this binomial is at 1 degree, while at our q of x degree 1. So our q of x is in 2. Okay, so the degree of px is less than the q of x because 1 is less than 2. That's why it is under the proper rational fraction, and we can immediately apply the technique of integration of rational fractions. But in our second example, we have x squared plus 1. So this is our p of x. And for our q of x, we have x squared minus 1. Okay. So as you can see here, the degree of p of x is in terms of 2. Then the degree of the q of x is also second. Okay. They are both in second degree, so degree of the numerator and denominator is equal, wherein we need to make it a proper rational fraction in order for us to use the integration of rational fractions. Okay, so how can we by the way, this is called improper rational fraction. So this example is a sample of improper rational fraction. Okay, so how can we make this improper rational fraction to proper rational fraction? Okay, so by simply performing a indicated division first. So we need to divide it first before we do the rational fractions. I mean the integration of rational fractions. Okay, so x squared minus 1 all over x squared minus 1 d of x. So you need to divide it first. Okay, but my technique is just this is plus 1. My technique is just I do some modifications using only an algebra. Okay, you can also do the division if you want, but my technique here is just do the algebra. Say we have x squared plus 1, right, all over x squared minus 1. So at my denominator we have minus 1. So I want my numerator to have minus 1. So I will add minus 1. And in order for this equation to what do you call this, to be equal on its original equation, then I will also add 1 because minus 1 plus 1 is just 0. So technically we are just adding 0, which will not affect the entire entire equation here, right? So we have dx. Okay. And from here we can now do the proper division by a grouping x squared, then minus 1, and then our plus 1 and plus 1. So we have 2, right? All over x squared minus 1 d of x. Okay. Then by simplifying it further, we have x squared minus 1 all over x squared minus 1, then plus this part 2 all over x squared minus 1 dx, right? So after this, you can now easily see that this is equal to 1. So we have the integral of dx plus integral of 2 all over x squared minus 1 d of x, right? Okay. So from here, you can now easily integrate this part, the integral of dx. But for this part, we need to do some integration techniques in terms of rational fraction, or in this case, we will do the case 1, which is the denominator consisting of distinct linear factors. Okay, so let's rewrite this the other side. Okay, so let me copy our problem. So we have dx, then plus the integral of 2 x squared minus 1 d of x. Okay, this part here, we have the integral of dx is just x, but for this part, we have a separate separate solution for this one. So we can now use partial fractions, wherein this is also equal to, by doing the completing up squares. So we have the x, and then we have negative 1, so we have here a positive 1 and negative 1, right? Okay, so after we do this, then we will now use our form in terms of partial fraction, wherein we will use this form. Okay. So here we say that this is now our technique, it is also equal to a all over this part x plus 1 plus b all over x minus 1, right? Then right after this, we will multiply it by its LCD. So we have x plus 1, x minus 1. So what we have left here is 2 is equal to a times x minus 1 plus b times x plus 1, right? And then we will now find the value of a and b. So say first, let's find the value of a by letting our b vanish, or by letting our x plus 1 is equal to 0. Okay, so we have x is equal to negative 1. So if we let our x is equal to negative 1, then what we have here is 2 is equal to a times negative 1 plus b times negative 1 plus 1. So negative 1 plus 1 is just 0. Negative 1 minus negative 1, I mean negative 1 minus 1 is negative 2. So 2 is equal to negative 2a, or a is just equal to negative 1. Okay, so to find b, find b, let our x, we will make this term vanish. So we will now let x minus 1 is equal to 0. So our x is equal to 1. So if we let our x is equal to 1, then from our equation, our equation will become 2 is equal to a times, if we let our x is equal to 1, we have 1 minus 1, then plus b times x, which is 1, 1 plus 1. So we have this is 0. So 2 is equal to 1 plus 1 is equal to 2b, or b is equal to 1. See, we have 2 over 2 is equal to b, or 1. Okay. So our the values of a is equal to -1 and b is equal to 1. Okay. We will use this one. So from here we can now integrate our okay. From here we can now evaluate our integrand, this one. So from a all over x plus 1 plus b all over x minus 1 b of x, and by having the value of a and b, so we have negative integral of dx all over x plus 1 plus b, which is 1, so we have only dx all over x minus 1, right? So from here we can now easily see that the integral of dx all over x plus 1 is just, we have negative sign here, negative ln of x plus 1, and then plus integral of this one is ln of x minus 1, then our plus c. Okay, so all in all, we have to add this one, right? Because we have the integral of dx plus the integral of this one, which is equal to this one. Okay, so all in all, we need to add x here. How can we write this? So let's rewrite it first. So so the integral of dx plus integral of 2 all over x squared minus 1 dx just equal to integral of this one is x plus the integral of this part here is this one. So we have negative ln x plus 1 plus ln x minus 1, then our plus c. So we can simplify this by doing some modifications in our integral. So we have x, we have negative sign, then this will go at the denominator, so we have x plus 1, then our plus is x minus 1. This is positive, so this is at the numerator. Okay, and then our plus c. Yan. So our final answer is x plus ln of quantity x minus 1 all over x plus 1 quantity plus c.